This is an example of finding the unknown angle in a right-angled triangle using trigonometry. The question asks us to find the unknown angle theta correct to the nearest minute. We start by labeling our sides. If this is our angle theta, this side is the adjacent side, and the longest side opposite our right angle is the hypotenuse. So when we have adjacent and hypotenuse, we use our cosine ratio. Cosine theta equals adjacent over hypotenuse. Now you remember this question is asking us to find an angle here, and our angle is included in our cosine function right now. So we can actually use our inverse cosine ratio straight away to help us to find that angle. So you remember that's angle equals the inverse cosine of the adjacent over the hypotenuse side. You can jump straight to this step, writing down this version or the inverse version of our cosine ratio. We substitute in our values. The angle theta is equal to the cosine, or the inverse cosine of our adjacent side, 17, over our hypotenuse, which is 40. You can put that in your calculator, and that should give you 64. Theta equals to 64.849, and a few more decimal places, degrees. Now this question has asked us to find the angle correct to the nearest minute. So we need to convert this measurement as degrees to an angle using degrees, minutes, and seconds. And the way that we do that is by pressing the degrees, minutes, and seconds button on your calculator. And that will give you 64 degrees, 50 minutes, and 50 minutes, not 50 degrees. We've already got a degrees measurement. 50 minutes and 57.61 seconds. We need to round off to the nearest minute. These are our minute values here. The value that tells us whether we should round up or not is our seconds. 57 seconds, that's almost to 60. We're going to round that up to the next minute, which will give us theta equal to 64 degrees and 51 minutes. And that is the size of our angle, the unknown angle theta in our right angle triangle, correct to the nearest